how are you? So, in today's session, we are going to talk about the frequent item sets and the rules. So, basically, the frequent item sets means the sets of the items or set of the things which we take under the association rule learning. Like if we are considering the two items or the two objects, and when we make a set of that, then we can say that frequent item set or the rules through which we get the frequent item set. So let's start with the today's session of frequent item sets and the rules. Here are very brief definitions of some terms. First of all, we talk about the association rule. Example like X and Y. When we bought X is the representation of finding Y on the basket which has X on it. When we already bought X, then we are finding that how many of customers will also buy Y also. Item set example X comma Y is the representation of the list of all items which form the association rule. And this is like when we consider two items at a time, then we say that it is a item set. Support fractions of transaction containing the item set. The fraction of transaction containing the item set means the out of the total number of transactions, how many person buy this item set. Confidence probability of occurrence of Y given X is present. So how many number of chances that if person buy Y when their X is already present, and lift is equals to the ratio of confidence to baseline probability of occurrence of Y. So basically lift is trying to figure out that there is relationship between the two items or not, and trying to figure out that if two items are not in relation, or there is very much relationship in between the two items, and that's what is lift about. And now but that we are familiar with these terms, now let's proceed ahead with extracting the rules from a list of transactions. The very first step in the process is to get a list of all the items occurring at least once in our set of transactions. The challenge is the mining of important rules from a massive number of association rules that can be derived from a list of items. So basically, here the challenge is like we have to figure out the list of items that occurring the at least one in our transaction that were bought by the customer, and after that we have to make some n number of rules, and from that n number of rules we have to figure out those rules which are important to us, which are important rules, and neglect all those rules which are not appropriate. So next, remember, rule generation is a two-step process. First, to generate the item set like bread, egg, milk, we have to generate an item set. And second is to generate a rule from each item set. Like we have to make a rule like if we bought bag bread, then we can bought also egg, and we can also bought milk. Next rule is like if we bought bread or egg, then there is more chance like we can also bought milk, and etc. Some other rules. Both the steps are discussed in the next slides. So now let's come to the next slide, which is first is generating item sets from a list of items. First step in generation of association rules is to get all the frequent items on the which binary partitions can be performed to get the antecedent and the consequent. So basically our first step is to get the make the generation. First step is the generation of association rule for all the frequent items. Make as much as you can rules, make on the n number of association rules that you can from the antecedent and the consequent. For example, if there are six items like bread, butter, egg, milk, notebook, toothbrush, and we have these six items on the transactions combined, we are some item sets. We look like bread, butter, bread, notebook, milk, toothbrush, milk, egg, vegetables, etc. Like if we have a item set containing these six items, then we make sub items from that, some sets from that item set. Size of an item set can vary from 1 to the total number of items that we have. So basically, the item set can be varies from the 1. The size of item set can be varies from the 1, and the total number of items which are available in the retail or store, that is the size of the maximum size of the item set. Now we seek only frequent items from this and not also as to put a check on the number of total items generated. So the now we is going to see the frequent item sets which we get, like these are the all item sets, and from that we trying to figure out the frequent item sets by calculating the support greater than minimum support, like from the threshold value where we get the support value more than the minimum support, we calculate those frequent items. Frequent items are the ones which occur at least a minimum number of times in the transactions. Like we are specify the some minimum number of transactions, the and at that time the item sets where which are occurring more than the minimum number of transactions, we are considering those item sets. Technically these are the item sets for which support value fraction of transactions containing the item set is above a minimum threshold. Minimum support means we specify a threshold value. If an item set having support greater than the minimum support threshold value, then we consider those item sets. So bread notebook might not be frequent item set if it occurring only two times out of the 100 transactions, and the probability or the number of times it bought is the 0.02 falls below the value of minimum support. Like if we have a minimum support of zero point 0.5 and the according to this number of transactions of the item set bread and notebook, we get the this value for this the support of this bread and notebook is about 0.02, so it is less than minimum support, so we discard this bread and notebook item set. Next, a brute force approach to find frequent item set is to form all possible item sets and check the support values of each of these. A priori principle help in making this search efficient. It states that the all subsets are frequent item sets must also be frequent. So basically, if we apply a brute force where we make all item sets, all the possible number of item sets that we can make, then it is very difficult. Then it will take very computation power and take much power, take more of resources. But according to the a priori principle rule, if we apply this a priori principle rule, it is an efficient way to find out the item sets which are brought frequently. And it says that the if we have a frequent item set having the n number of items, then the subset of that frequent item is also be a frequent. This is equivalent to saying that the number of transactions containing bread egg is greater than or equal to the number of transactions containing the bread egg and vegetables. If the latter occur is 30 transactions, former is occurring in all 30 of them and possibly will occur in even some more transactions. So if support value of bread, egg, vegetables is that is 30 out of 300, which is 0.3 is above minimum support value threshold value, then we can be assured that support value of bread and egg that is greater than 0.3 or equals to 0.3 is above the minimum support value. This is called the anti-monotone property of support, where if we drop out an item set from an item set, if we drop out an item from the item set, support value of new item set generated will either be the same or will increase. A priori principle allows us to prune the supersets of an item set which does not satisfy the minimum threshold condition for the support. For example, if milk and notebook does not satisfy our threshold of minimum threshold value, an item set will with any item added to this will never cross the threshold 2. The methodology that result is called the a priori algorithm. Steps involved are generate all the frequent items greater than support items support greater than or equals to minimum support having only one item. Next, generate item set of length length 2 as all possible combinations of above item sets. Then prune the ones of which support value fell below minimum sub or threshold value. Now generate item sets of length 3 as all possible combinations of length 2 item sets that remained after pruning. So when we get possible combinations of length 2 item sets, when we prune the length 3 item set and perform the same check support when we get all the set of length 2 item sets, then we have to again perform a support value. Then we have to again check the support value for all those length 2 item set, and we keep increasing the length of item sets by one like this and check for the threshold at each step. As can be seen from the graphic, pruning of infrequent items reduces the number of items to be considered by more than half. This proportion of reduction in computational power becomes more and more significant as the number of items increases. This proportion also depends on the minimum support threshold minimum sub that we pick up, which is completely subjective to the problem at hand and can be based on the past experience. So by this, when we get the item sets and we reduce the item sets and we just get the and we just filter out the item sets from the all the item sets by using this minimum threshold value, then the generating all possible rules from the frequent item sets. So basically at the end we get the item sets which having the minimum support greater which having the support greater than minimum support, and like this we get the all the item sets which we want, and we it will take the less computational power. And next is like generating all possible rules for the frequent item sets. Once the frequent item sets are generated, identifying rules out of them is comparatively less taxing. Rules are formed by binary partition of each item set. If bread, egg, milk, butter is a frequent item set's candidate, rules will look like egg, milk, butter. If we buy these three, then the customer also can buy bread, milk, butter. If person buys these three items, then the person can also buy egg, bread, egg. If we buy bread and egg, then the person can also buy milk and butter. If you buy egg and milk, then the person can also buy bread and butter. And if you buy butter, then the person can also buy bread, egg, and milk. So that's how we make some rules from the frequent item set. From a list of all possible candidate rules, we aim to identify rules that fall above a minimum confidence level, minimum conf, just like the anti-monotone property of support confidence of rules generated from the same item sets all also follows an anti-monotone property. And it is an anti-monotone with respect to the number of elements and the elements in consequent. This means that the confidence of ABC, after we buy ABCD, we can ABC, we can also buy D is greater than the if we buy BC, and we can also buy AD is greater than if we buy C is greater than when we buy C, we can also buy ABD. To remind confidence of X is to remind confidence of Y when we bought X, support of XY divided by support of X. As we know that support of all the rules generated from the same item sets remain the same, and difference occurs only in the denominator calculation of confidence. As number of items in X decreases, support X increases as follows from the anti-monotone property of support, and hence the confidence value decreases. An intuitive explanation for the above will be as follows. Consider F1 and F2. F1 is fraction of transactions having butter, also having egg, milk, bread. There will be many transactions having butter, and all three of egg, milk, and bread will be able to find place only in a small number of those. And F2 is fraction of transactions having milk, butter, bread, also having egg. There will be only be handful of transactions having all three, milk, butter, and bread, as compared to having just butter. And there will be a high chances of having egg on those. So it will be observed that F1 is less than F2. Using this property of confidence, pruning is done in a similar way as was done while looking for frequent item sets. T is illustrated in the figure in next slide. So yeah, the rule which we see is seen in this slide. Like, we find out a rule, and from that we just find out low confidence rule, and from that pruning rules we get these rules: D A B C, C A B D, B A C D, and we prune out those, and that's how we calculate some rules. Now, maximum frequent item set. It is a frequent item set for which none of the intermediate supersets are frequent. This is like a frequent item set X to which no item Y can be added, such that XY still remains above the minimum sub threshold. So basically, here we have a frequent item set. Here we have a closed frequent item set. Here we have a maximal frequent item sets, and here we see all baskets with one item added to bread and butter falls below the value of minimum support, and at least one basket with bread and butter has something different from egg and support for that basket is above threshold. All baskets having bread and butter also have egg, and support of the basket with bread, butter, and egg is above the value of minimum support. So now we go to the closed frequent item set. It is a frequent item set for which there exists no superset which has the same support as the item set. Consider an item set X. If all occurrences of X are accompanied by occurrence of Y, then X is not a closed set. So basically, the frequent item set, if we have the frequent item set having support greater than the threshold value, closed frequent item set, and the maximal frequent item set are those. And for the closed frequent item set is like when we bought bread and butter, then there is not egg in our basket. And the maximal frequent item set is like all the basket which has only bread, or all the basket which has only butter has lower maximum, has the support less than the minimum support threshold. And that's all for the today's session, where we talk about the frequent item sets and rules, where I just tell you about first the brief definitions of the some terms, then we talk about the how familiar are these item terms, and then we see how generating the item sets from the list of items, how we generate the item sets, and then we talk about the frequent item sets, how frequent item sets are generated. Then the a priori principle, we talk about a priori principle and how it work, how it used to calculate the frequent item sets. And we just use some criteria to prune the data and get the rules in much easier way. And then we generate all the possible rules from the frequent item sets by using some criteria like support, confidence, and at last, this is how we do the prune. Then we just talk about the more maximal frequent item set, closed frequent item set, and the frequent item set. So that's all for the today's session. Thank you. Bye. Take care. Stay motivated and keep learning.